Alrighty, so here I am again. I know that you folks are probably losing some steam. It's one of the last sessions. What I want to do today, I want to first of all say, it says workshop, but unfortunately it's not quite a workshop because some of the things that I had anticipated would be working live actually are not. And that's what we have to deal with something so new. So I'm gonna basically try to tell a story more with some code that I had written and I'm happy to share that you can reproduce hopefully on a Google Colab at home, which is pretty agnostic of whatever you choose to do. So what I want to talk about today is the full story of what is enabled by what we're building, right? It's not just a decentralized storage solution. It's not just the FVM. It's not just compute. What interests me, or I guess why I joined Protocol Labs, was to build an end-to-end solution that enables a data economy. And I know that the Compute Over Data Summit it's happening today, also tomorrow. There's plenty of cool stuff there. But I also wanted to give the opportunity for this audience to understand how certain things might fit together and why this is so cool. Like, why are we building all this? I want to start with the master plan. This is probably something you've already seen, where João likes to say there's 3 steps, right? Step 1 is build the largest decentralized storage network. We have used cryptoeconomic incentives to build an incredible amount of capacity. But then really the question is, well, what do you do with this? We don't want to be in a helium situation, right? Where everyone's like, man, no one's really using this. Or like Decentraland, I don't know if you saw that a few days ago, where people were like, oh, well, this is worth $2 billion, but there's like 40 people using this. Like, what's the deal? You know? So usage is going to be a function of utility, not just in terms of the onboarding, but fundamentally also bringing the compute to that data or to the state on the blockchain. And really that's going to unlock an insane, in my opinion, data economy that I think is going to be, transformative if we manage to execute. So I want to tie this all together, and I just wanted to give you a few examples. I want to caveat by saying it's probably not going to take 40 minutes. Thank God. But I hopefully just want to impress on you a few interesting use cases that I felt were pretty cool. I started off my career in data science, and I spent most of it in a big tech company where I was beholden to centralized infrastructure, and I was always very frustrated that we were building some of the best machine learning models in the world, but not really able to share them, not really be able to share the value they created back to the data owners, to the labelers. And so I just wanted to give you some cool examples of what's possible today and what might be possible in the future. All right, so a couple of things that we're going to do. First of all, I'm going to give you an example of how we can use data on IPFS and compute over data to go from this, which is a dash cam frame, to this, right? Just typical object recognition. It's a really standard task, and it is something that for autonomous vehicles is, something you need, obviously, to understand where are the other cars, where are bicycles, where are the people, to make sure you don't hit them. The second thing we're going to do is go from that video, which is a NASA archive of the landing on the moon, to a transcript of the audio. Right? So these are like real tasks, especially in a machine learning world that, we have crazy cool models that are coming online, open source, things like stable diffusion, like everything from generative, from image to text, text to image, and whatever, everything in between. There's some really, really cool stuff happening out there. And so I wanted to just give you some examples of how you can literally do that today using compute over data, which I think is awesome. I've already showed you this slide. It starts with onboarding data to Filecoin. We are doing a lot of work to abstract away the complexities involved in this. And so, this is checkmark 1. Hopefully, there are enough tools today, actually, that you can use to put the data in a format that is decentralized and that you can use either from IPFS or through Filecoin. So I won't spend too much time here, but my bigger point here is this is something that exists today. None of the things that I'm going to show today are fully baked products, but I want to really highlight that you can do some really cool stuff with the stuff that is already built, even if it's 20%, 30% there. So putting data somewhere, right? How does it work? Generally speaking, it's one of 3 ways. There is via an on-ramp, right? There's the method number 1 Generally speaking, you're talking about something along the lines of Web3.storage or estuary, where you have a third-party hosted service that is doing the data transformation for you, and it's sort of like a plug and play almost, right? Or plug and pray, as Shrek like to say. So you just hope that it gets there eventually. Then there is a mostly client-side option, right? This is the example of a enterprise taking their data that is on-prem and leveraging some tools. It could be like, Go Car, for example, to take some data and transform it into some car files and then basically ship them over to a storage provider where they will do the sealing. And then there's kind of the opposite, right? Where I, as a company or as a research institution, might not have the technical know-how or the resources to do all this stuff on the client side, but I have way too much data for an on-ramp. I can't just do 5 petabytes of data using estuary. And so I will just basically ship some raw data, I'll encrypt it, and I'll ship it in some hard drives to a storage provider who will then do it all for me. And so I want to really highlight that in terms of getting data to the network, there's many different ways. And I welcome you all to talk to us at Protocol Labs to figure out what might work, whether you're a data onboarder or whether you know someone who is. So the thing that I am going to discuss today is something that looks somewhat like this, where I'm going to highlight some ways in which you can get data into IPFS, take that data and do some computation over it, and also leverage Filecoin as a way of archiving that data, right? So if I'm a machine learning researcher, why is this important? It could be for many reasons, right? Number one, I have collected valuable training data. I don't want thousands and thousands of images or videos just sitting around. I might want to just archive them to Filecoin. If down the line another researcher wants to reproduce my experiment, they know exactly what CIDs I might have used. They know exactly the sequence of steps necessary to transform them using another sort of CID, but for data transforms, and so they can reproduce it. I don't have to waste valuable hard drive space. If other researchers also want to download the data that is available in IPFS or Filecoin, they are free to do so. And above all, right, when it comes to compute over data, this is a really incredible promise of the sort of eventual end state that we're shooting for of storage providers co-locating storage and computation, where I can actually run things in a decentralized manner in a way that I'm not beholden to large Web2 cloud providers to do it. So this is the general thing that I'm going to architecture somewhat, that I'm going to explore today with you to achieve those 2 tasks that I talked about. So step 1 is onboard data. Step 2 is do some compute over it. Step 3 is retrieve. I will talk a little bit about the end goal of actually doing this all in a Filecoin ecosystem that does not exist today. And so I'm taking many shortcuts right now, where I'm just using IPFS as really a proxy for what Filecoin might become in terms of its ability to efficiently serve retrievals, for example, as one example. So example number 1 is, I want to take some data that might exist in my Google Drive. As an example, I might want to put it on Web3.storage or estuary, and in doing so, I just put it on IPFS, and then I want to run some compute over it. So very simple code, actually. There's many ways to use either of these tools. There is something like estuary.tech, where I can actually go in here, I can sign in, and it allows me to have some sort of a, oh yeah, so this is why I didn't do this. Hold on, Web3.storage to the rescue. All right, cool. So I can actually manage my files, and I can actually have a user interface that allows me to onboard files onto IPFS and Filecoin in a very seamless manner with a web UI. Of course, this doesn't really work if I have tons and tons of data, but it is a good way to get started, so I encourage you to explore this option. If you want to play around with compute over data after this session, and you just want to onboard, 10 pictures or 100 pictures or something not that big, you do have 1 terabyte of data, which is great. But what I wanted to show you is, it actually really is straightforward to use other methods, right? you could use an API, right? And just make a simple post and basically attach a file to that request, and that's it. It'll work. So, right now I can, let's see, this is, web3.storage. I've attached my key here. All right, and I can, let me just transform that response, and I can print a CID, and I can create a gateway URL, and there you go, right? Super, super easy, almost instantaneous. They're using Elastic IPFS. It's really cool. So for experimentation, it actually works really well. And so you can do this. You can onboard a bunch of data pretty easily. If you are scared of code, you can even use something like this, which I didn't know existed until last night. It's so easy. It uses the same thing in the backend. It actually just gives you a CID for a folder, and then the respective, you click into that and you see all the different CIDs and within that folder. There are command line tools. There's so many, there's so many things you can use to onboard your data. If we're talking about a sort of sub 15, I would say in my experiments, anything above 10 to 15 gigabytes starts getting a little iffy. But yeah, it'll do the trick. So you can use any of these tools to onboard your data. And these are very useful because, you can just share this link using a CID. You'll know exactly what you get. Now, Bacalhau is a solution that is being built by other folks within NDRES inside of protocol labs aimed at doing distributed computation over data. And so it is actually also very, very easy to run. What it allows you to do is to just specify an arbitrary Docker container, and it'll execute that on some remote magical thing, and it'll return the results. It's very straightforward, right? So in this example, by the way, I will share this with you. This is very easy to rerun. So go ahead, you can install Bacalhau. Bacalhau, by the way, is Portuguese for COD. COD is an initialism, COD. COD, compute over data. It's a big stretch, but I've had several people ask me, like, why the hell is it called Bacalhau? Especially Portuguese people who are like, what? So you can, it's really as easy as this, right? Where you can specify what you want to run. You can even give it runs GPU jobs, which is pretty nice. So for all ML type stuff, it does both training and inference. You can specify then where you are serving, where to pull data from. So in this case, this CID is essentially just a folder to which I uploaded a couple of pictures, right? And I uploaded those pictures of my, a bunch of pictures of the dash cam footage, right? And so you point to this, you give it a Docker container. In this case, I'm using YOLO v5. YOLO is a common ML model for object detection. It's right off the shelf, and then you basically give it the command. I'm giving it, say, hey, go run detect.py, and use this checkpoint that I also onboarded to IPFS. Here's the source, and give the outputs. Put the outputs on this folder. You'll run it. It'll go through this. I wanted to do this all live, by the way. I'm sorry that I can't. It's way more engaging, but hopefully I don't want to linger onto this too long. It'll do the job, and it's surprisingly fast too, which is pretty great. And so, even though this is just in the beginning, I was really excited that I was able to just, go ahead and use this solution and get a Tesla T4 GPU to go and do my ML inference. So I did all that. I created a directory for my results, and I get my results. And it's actually really, really cool. If I go here and I go to my Lisbon demo, oops, there you go. That's a CID that represents the folder in IPFS that contains my, come on. Oh my God.
Google Chrome doesn't work, unfortunately.
All right, there you go. There you go. So these are different frames of that video. I pre-processed this to use FFmpeg to just basically extract a handful of frames. But that's that. It's really simple. And it did this in, I believe, a few seconds, which is pretty cool. So once the resource is provisioned, it'll execute really quickly. And there you go, right? So it's pretty neat. The other thing I experimented with that is also really exciting is, let's say you're generating video, right, or using something like Stable Diffusion, and you're running at 60 frames per second. You could, in theory, parallelize this across 60 machines and have it run way faster instead of doing it sequentially. So I encourage you all to experiment this. Maybe I'm just nerding out on my own up here, but I think this is pretty cool. So that's one example. Example number 2. By the way, once this is here, I could do a bunch of stuff, right? I could use Estuary to take those CIDs and say, hey, shoot this over to Filecoin. It's already there. It'll happen pretty quickly. All Estuary does is it waits for there to be a 32 gigabyte sort of collection of files, and then it shoots it off to storage providers. In the future, this is going to be way, way, way more seamless. And if you're in an environment like Colab, which I'm very familiar with, it's very easy to just basically say, hey, take this stuff that I just did and put it on Google Drive. I could use something like rclone to take my stuff from Google Drive and then put the results straight into Estuary. It can be pretty neat. Here's another example of machine learning model inference, where it is a speech-to-text model, right? OpenAI just released their Whisper model. It by far beat all their state-of-the-art for speech-to-text, which is basically automatic speech recognition. What it does here is it will take video or audio or anything else. It'll auto-detect the language, and it'll convert it to text. It's really, really cool. So I think the use case here might be automatically creating captions for YouTube videos in any language with really high accuracy. And so really what we did here was, take OpenAI Whisper. It's literally just a Python script that basically takes an MP4, uses FFmpeg to extract the audio, parse the audio, and then pipe it through here, and it'll spit out. You basically use bacalhau get. You basically use the ID here, and you can get the results, the transcription. And so, I don't know why. There we go. Lisbon, Whisper, raw. Oh my God. I don't know why. There's some. There you go. So there it is, right? Again, not particularly remarkable, I think, but in terms of just one video. But I think it's really cool that you can actually just take some content that's hosted on IPFS. And one day when we have better search engines for all this stuff, you could imagine the sort of data economy that can be created by just taking data that's already there in public and just doing these transforms. And so both from a standpoint of the amount of data that's just waiting there to be processed and mined, it's incredible, but also in terms of the compute that we have access to. Alrighty, so that was video to transcript. All right, now, of course, many people here who are more familiar with our stack will be quick to point out, okay, you're way over-promising here and under-delivering because I'm basically pulling stuff from IPFS. I'm not actually taking it from Filecoin. If you did want to get it from Filecoin, I'd have to do Lotus Retrieve. Hopefully that they have an unsealed copy. Make sure that it's retrievable, get it, and right? I'm also just doing computation over the data itself. I'm not doing computation over the state, right? So what about smart contracts that can be used to launch jobs? Not there yet. And so this is a very classic case of grass is greener on the other side. I promise you it is. And I believe pretty strongly we'll get there, perhaps not in Q1 2023, but soon enough. And I'm excited to see what comes out of it. And as an example of, here's what it's going to take, right? I can imagine a bunch of really cool tools working in concert, right? You have something like Singularity to onboard vast amounts of data and keep it all clean and index it all. You can use something like Bacalhau for compute over data that I just showed you, the FVM, of course, allowing you to compute over state, and Saturn for much easier retrievals. And so all of these things in concert, I think, are going to provide a much more exponential utility, I believe, in the next year. So here's something that I am personally pretty keen to explore next year as these things, as the pieces of the puzzle fall together, right? Like, let's say that you are some end user who is providing user data. Could be behavior data. Let's say it is voice data, right? Like we speak to Siri and our Google Homes every day. Imagine the idea of storing all that data on Filecoin and then creating a system by which that data can be labeled, right? Let's say you're talking about a supervised machine learning model that requires me to have data that has labels. In other words, I have a bunch of utterances in English. I want to create a machine learning model that transcribes English audio to text. I need to have many, many, many thousands of examples of actual people speaking in English alongside their translations. Just like for computer vision models, I need to have actual human beings draw bounding boxes and really show a supervised learning model what is a tree, what is a car, what is a dog, etc. Right? So in this example, right, you can have something where perhaps using the FVM, a combination of the FVM and compute over data, you can create a whole data economy where I can create something like a labeling platform that allows people to label actual data that exists on the Filecoin network. In return, they might be paid out by the model creators, by the researchers or the companies that leverage those models. I can use compute over data to do the ML model training. And as a result of that, I'm going to have new synthetic data that can be used for future model training, as well as new models that, when used, we can use the whole chain of custody over this whole thing to identify just exactly how much did people contribute to the creation of this model in terms of the data that was needed to train them. And then actually, let's say this model generates $100 million in value and utility for someone. If I contributed just 1% of that data, I mean, it's probably not going to be as simplistic, but let's say that I did, you could in theory reward people for the amount of data they contributed directly and verifiably, which is really, really, really cool in my opinion. And so, you could have a whole ecosystem, right, where Phil is paid out to data owners, Phil is paid out to labels, Phil is paid out to the people who actually created those models, right, for the actual code in terms of the model architecture. Really cool stuff. So just one example of something I believe could be done in the next year as all these 4 pieces fit together. So that's the end of the talk, right? Went over IPFS, compute over data, how these things fit together. Really want to impress on you that, this is early days, but you can do some really cool stuff already, and you can going to be able to do stuff that is 100 times cooler next year. It's really striking when you can use stable diffusion to generate whatever artificial pictures of dogs or cats using a decentralized network. It's really awesome. So I will be sure to give you the URL for the collab. You can run this on your own. Collab's free. You'll get to see, step by step. And I encourage you to play around with this.